Hey, what's up? It's Nate Mullins. I have a video tutorial for you on how to derive divisibility rules for any number ending in 1. Every number, believe it or not, does have a divisibility rule. There are sometimes multiple methods for certain numbers, but every number has a divisibility rule. And we're going to investigate numbers ending in 1, everything from, we'll review 11 again, all the way up through 101. We'll just do 2 through 101, and then I'll be done with all these tutorials about divisibility rules. But just for your interest, and this is going to blow you away because this is a formula that you may have never seen. First of all, let's recall the stem and leaf concept. Leaf is simply the ones digit of any number, and then the stem would be the number that's formed by the rest of the digits once you break off the leaf. So 57, the leaf is 7, the stem is 5. 189, leaf is 9, stem is 18, and 27,429 breaks into 2,742, and which is the stem, and 9, which is the leaf. So that's pretty simple, right? And the general formula here is S plus XL, and this can be used for all numbers ending in 1, 3, 7, or 9. Let's let L be the leaf. That's the ones digit I just showed you. S would be the stem of the number. That's everything except the ones digit. New number formed by those numbers. And for single digit numbers, it's implied that the value of the stem would be 0. Tens digit is 0 for numbers like 5 or 6. And then X, now that depends on, first of all, whether the number ends in 1, 3, 7, or 9, and then exactly what that translates into depends on the divisor, what you're testing divisibility for, in other words. So B will define it as the divisor. That's the smaller number for which you are checking divisibility. When you get a bigger number, the dividend A, and you're checking for divisibility by B, A over B would then eventually you'll get a whole number, and thus it's divisible. So it's important to realize that you're using this formula first of all as a derivation, and then you would take that number A and then you apply the derived formula to test for divisibility by B, your divisor. So recall the general process using S plus XL. This was done in the video tutorial of 7 and 11 and 8. But 7 and 11 we actually used this. 8 was a different method. Always start by breaking apart your dividend A into the stem and leaf. So you have two separate numbers. We'll call it stem S and the leaf L. So you perform some operation that ultimately involves multiplying whatever X is times the leaf, L, based on the formula that you derived for your specific divisor, like 11, 21, 31. Then you do something to that. You're going to either add or subtract, depending on, in the cases of 3 and 9, you're going to add, in 1 and 7, you're going to subtract. Now, the rules for 1 are the simplest. 9 is fairly easy as well. 3 and 7 are more difficult, especially 3. Real pain, because then you're adding stuff and you're going to get bigger numbers and it's going to be harder to do. So anyway, the product, you're going to add and subtract this product from S, and in most cases you're going to have to repeat. And if you reach a multiple of B, and that multiple can be 0 or a negative multiple of B, for instance, minus 7 and minus 14, when you do the test for 7, may be your final answer, or 0, and that's fine because, well, they're still multiples of 7. They're just 0 or negative 1 or negative 2. Thus, A is divisible by B with no remainder. So the specific formula for divisors ending in 1, recall the general formula, S plus XL. In the case of numbers ending in 1, x happens to be negative s. So it's just the stem, and you subtract that value of the stem times the leaf. You substitute minus x for s, thus, in this formula. So we get s minus SL. And I'm not factoring out an s and multiplying out by parentheses 1 minus L because, well, you're breaking it apart into two different numbers, so that sort of doesn't apply. So if you're wondering why I'm not factoring that out, it's sort of kind of a different, I mean, you're dealing with two different numbers and you broke apart the number. So let's use this formula to derive divisibility rules for divisors ending in 1. And for 1 specifically, you always, if you go far enough, you'll always eventually get 0. Always. I'll show you, it's just like magic. Okay, divisors ending in 1. Remember the general formula, s minus SL, because s plus x, but x was minus s, so that becomes a negative sign, and minus just s, L. So, for 11, it's the stem of your dividend A minus the leaf, and 11, of course, is B, your divisor. But you break your dividend into a stem and leaf, and you take the stem minus the leaf. And we did this in the earlier video that I posted for 7, 8, and 11. And this is just happens to be a special case of 11, and not coincidentally, it fits in right into this formula, s minus L, because the leaf is just 1, so s minus 1 times L is just s minus L, which is your divisibility rule for 11. For 21, well, your stem is 2, so it's going to be s minus 2L. For 31, s minus 3L. Notice the corresponding numbers in all of these. So we'll go through examples of each of these. So you can see the pattern here. So 61 would be s minus 6L, because that stem is 6. So what you would do to a particular number is you'd break it into a stem and leaf, and you'd multiply the leaf by 6, and then subtract it from the rest of the number, which is formed by the stem. And I'll show you specific examples now. 11, which is just s minus L, and 21, s minus 2L. Remember, the 2 is the stem, so s minus SL, s minus 2L. So let's prove some things. Show that 57,981 is divisible by 11. Seems like a daunting task, but it's actually pretty easy. 57,981, first of all, you break it apart. That's your very first step. 57,98 and 1. So you just subtract that 1, because it's just 1 times 1, from 57,98 to give you 57,97. Now you repeat the process. You break that apart into 579 and 7, and 579 minus 7. Again, it's implicit that it's times 1, but we don't need to do that. It'd just be extra work. And that gives you 572. And you do it again. Break 572 into 57 and 2. And of course 57 minus 2 would give you 55, which is clearly a multiple of 11. So you've already proved it. And of course, just for good measure, 5 minus 5. Remember I said everything would end in 0 eventually. 5 minus 5 gives you 0. So 5271 times 11 gives you this number here, 57,981. Again, this is A, and 11 is B, and then this is your other, 5,271. So we'll show that 17,976 is divisible by 21. So you again break this number here, your dividend A, into the stem and leaf. That gives you 1797 and 6. So in this case, you're multiplying the 6 by 2, and that gives you 12, and you're subtracting it from the new number formed by the stem. So that's 1797 minus 12, 6 times 2, and that gives you 1785. Repeat, break it apart. That gives you 178 and 5. 178 minus, remember you're multiplying the 5 by 2 now and subtracting it. 2 times 5 is 10, so you subtract that from 178 and get 168. Break 168 into 16 and 8, and you'll see that 16 minus 2 times 8 gives you 0. So we've just proved that 17,976 is divisible by 21, 856 times. 31 and 41, s minus 3l, 31, s minus 4l, 41. Show that 14,229 is divisible by 31. So you break that up into stem and leaf, 14, 22, and 9, and you take the 9, this time you're multiplying it by 3 and subtracting, so this gives you 27. We're doing this per order of operations here. I'm throwing in the parentheses, but you do the multiplication before the subtraction. So 9 times 3 is 27, but you're subtracting from 1422, that new number formed by the stem. 1422 minus 27 gives you 1395. You repeat, break that apart into 139 and 5. 5 times 3 is 15. You subtract that from 139 and you get 124. Repeat one more time, and 124 breaks into stem and leaf of 12 and 4 respectively, and 4 times 3 is 12, so 12 minus 12 is 0. So we've proved that 14,229 is divisible by 31. Happens to be 459 times. Show that 29,848 is divisible by 41. So we take 29,848 and break it up into 2,984 and 8. And so now you're multiplying the 8 by 4 and subtracting it from this. So 2984 minus 32 will give you 2952. Repeat, break that up, 2952 into 295 and 2. 295 minus 2 times 4 gives you 287. That's 295 minus 8. 287 breaks apart into 28 and 7, and now you can see that 7 times 4 is 28, so 28 minus itself is 0. So 728 times 41 gives you the 29,848. For 51 and 61, s minus 5l and s minus 6l, respectively. And to show that 56,406 is divisible by 51, again, same procedure, break it up into 5640 and 6, take that ones digit, 6, multiply it by 5, 30, and then you subtract it from 5640, and that gives you 5610. And this one you can almost bypass because, well, you're going to just get 0 here. So 5610 breaks into 561 and 0, and then you could, that doesn't change, so 56 and 1 is your next result when you repeat, and 56 minus just 5 times 1 gives you 51, which is of course a multiple of 51. And take that a step farther, 5 minus 5 times 1 again gives you 0, and that is 1,106 times 51 to give you 56,406. Show that 51,423 is divisible by 61. Well, again, break the number up. You get 5142 and 3. Multiply that by 6 this time. Gives you 18. And subtract it from 5142. You get 5124. Break the 5124, repeating the process. Break that up into 512 and 4. And 512 minus 4 times 6 is 24. So you subtract that from 512 and get 488. Break the 488 into 48 and 8, and of course 8 times 6 is 48, subtracted from itself is 0. So we've just proved that 61 is divisible by, or rather 51,423 is divisible by 61, 843 times. So just a few more examples. S minus 7l is the rule for 71, and s minus 8l is the rule for 81. Show that 68,444 is divisible by 71. Take the 68,444 and you get 6844 and 4 when you break it apart. 4 times 7 now, that's 28, and that's subtracted from 6844 to give you 6816. Then you repeat, break that up, and do 681, and 6. 681 minus 7 times 6, that's 42, gives you 639. Break up the 639 into 63 and 9, and, well, now 9 times 7 is 63, subtracted from itself is 0. 964 times 71 is 68,444. For 81, show that 60,588 is divisible by 81. So you break that up into 60, 58, and 8. And 8 times 8, of course, is 64. And then subtracted from 60, 58 gives you 5,994, which you break apart then, repeating, into 5, 99, and 4. And 4 times 8 is 32, and subtracted from 539 is 567. 567, break apart one more time, 56 and 7, and of course 56 minus 7 times 8, which is 56. 56 minus 56 is 0, and that's 81 times 7, 48, is 60,588. And finally, 91, S minus 9L, and 101, S minus 10L. Hopefully by now you can clearly see the pattern. And just two more examples for you. Show that 35,126 is divisible by 91. So you break it apart, 35, 12, and 6. 6 times 9 now is 54. Subtracted from 35, 12 gives you 34, 58. Break it apart again into 345 and 8. 345 minus, again, it's 8 times 9, which is 72, gives you 273. And you break the 273 into 27 and 3, and of course 27 minus 9 times 3, which is 27, is 0. So 91 times 386 gives you A, which is 35,126. And finally, for 101, show that 62,418 is divisible by 101. Break 62,418 into 62, 41, and 8. Well, this is pretty easy. 8 times 10 is 80. Subtracted from 62, 41 will give you 61, 61. Break that apart and you get 616 and 1. Well, 1 times 10 is 10, so you subtract that from 616 to give you 606. 606 breaks apart into 60 and 6. It should say 60 and 6, but anyway, 6 times 10 would give you 60, so 60 minus 60 is 0, and 618 is the number you multiply by 101 to give you 62,418. So the new numbers we've learned, 11, I'm going to be 2 slides here. 11, you subtract the ones digit from the rest. 21, you subtract twice the ones digit from the rest. You can also test for divisibility by 3 and 7 if you so prefer. 22, check for divisibility by 2 and 11. We kind of went over this in the last one, but just to sort of reiterate, because we covered 11 again here. 31, you subtract 3 times the ones digit from the rest. 33 has to be divisible by 3 and 11. 41, subtract 4 times the ones digit from the rest. 42 is divisible by, you can use 2 and 21, or you can test for divisibility by 2, 3, and 7, or 6 and 7. And their least common denominator is 42, so you can use that test as well. Either method will work. For 44, divisible by 4 and 11. For 51, subtract 5 times your ones digit from the rest. 55, divisible by 5 and 11. 62, subtract 6 times the ones digit from the rest, and then 62 has to be divisible by 2 and 31, so even and divisible by 31. 63, we already covered before, you can use divisibility by 7 and 9. You can't use 3 and 21 because 21 is divisible by 3, and so the least common denominator is not equal to 63. So divisible by 7 and 9, that's sort of just making a note here that you can't use 3 and 21, which we just learned. So stick to 7 and 9 to test for divisibility by 63. 66, divisible by 6 and 11. 71, you subtract 7 times the ones digit from the rest. 77, divisible by 7 and 11. 81, subtract 8 times the ones digit from the rest. 82 now, that's divisible by 2 and 41, so even and divisible by 41. 84, we went over that last time. You can use 4 and 21 since their LCD is 84, or you could stick to the method I showed you before of having it testing for divisibility by 3, 4, and 7. Notice 3 and 7 makes 21 and 4, so it really doesn't matter. 88 has to be divisible by 8 and 11. 91 you subtract. Now you could use 13 and 7, but that would be you'd have to use two processes to figure that one out, and when you can just do it all in one, subtract 9 times the ones digit from the rest. That's why I showed you the separate, because doing 7 and 13, which we haven't learned yet anyway. You learned 7 before, but not 13, so we'll stick to this method. It's much easier. It's half the work anyway. 93, you check for divisibility by 3 and 31. And then for 99, you check for divisibility by 9 and 11. Finally, for 101, like I showed you in that slide 2 slides ago, subtract 10 times the ones digit from the rest. So that concludes this presentation. Next up, we'll be discussing the new magic formula for deriving a divisibility rule by 3. And that's all, folks. Thanks for listening.